This video is for a gentleman out there who is currently working on a project regarding I think it's a bingo game machine. It has an array of 80 LEDs, and what he's trying to do is display those 80 LEDs on a remote display. So he's trying to tap into the LEDs of the display he currently has and replicate that display on a much larger custom-made display, I guess for viewing in a bingo hall or something like that. So I'm making a few assumptions maybe about the schematic that he has inside of this machine, but from what I've been told so far, he's basically got something along these lines where there's an LED inside of inside this LED array. There's a resistor that it's connected to, and then that LED is then connected to ground. So out here somewhere is a microcontroller that's lighting up this LED. So these are red LEDs, and this resistor value is unknown, so we don't know what this is. We know this is a red LED. He was trying to determine, could he piggyback off of this? Could he, add a resistor and another LED and do something off onto his own display? And that may be possible. I'm not sure what kind of drive current circuitry out here is capable of delivering, so we don't know that. I had him do a voltage test in this neighborhood, just trying to find the forward voltage drop of this LED, and he got, I think he said, a half a volt, and that I was kind of perplexed by that for a minute, but then I thought, oh well, it must be that this is doing some kind of multiplexing, so this is sending a PWM signal to this red LED. That's something like a 30 or 25% duty cycle, because a real LED should be in the 1.6 volts to 2 volt neighborhood. So what I suggested, and this is the reason for this video, is that he follow a transistor approach and tap into the LED at this point and use something like a 2N222 transistor to power each LED in his large array. So he sent me some specs of the LEDs that he has, and they are 20 milliamp, and they're 3.0 to 3.2 volt LEDs. So I came up with a kind of a schematic and tested out for what I believe will be adequate to drive each of these LEDs. And I'm going to be working with the assumption he had mentioned a 12 volt power supply, so he can power this alternate display with the 12 volt power supply. So we'll kind of work through this. So we're going to say we have a plus 12 volt power supply. We're going to be tapping off this LED here. We're going to have some kind of resistor going into one of these LEDs that he has. It's going to be one of his LEDs. Pardon my fantastic drawing skills. Light emitting diode, and this is going to be going into some kind of transistor package. I chose for what I was doing a 2N222. He may choose some other NPN type transistor. 2N222, 4 2s on there. Then coming off of this, we'll have some sort of resistor here, And so when this LED is illuminated, it's going to have, there'll be adequate voltage here to activate the transistor base and turn on the LED. So we'll run through a few calculations to determine what are these resistor values that we're going to need. So to start with, we know that there's going to be from the data sheet between ground and the base of the transistor, there's going to be about 0.6 volts. This is the voltage that's going to be required to even turn the transistor on at all. And in order to get, I'm just going to do a base current because this is just 20 milliamps for this LED. I'm going to do a base current equal to 1 milliamp. That should be enough to turn the LED to full brightness. He may choose a resistor value a little bit differently so that he gets a little bit higher current through to get full brightness. He may have to do a little bit of tweaking, but we can get a good rough number as to what this LED should, or what this resistor value should be to get this LED to light up, and for this wire to be a very low gauge, so he can bundle them up and then have 200 feet of wire that he may need to use. So since this is going to be a 1.6 to 2 volt voltage range, and we're going to have a 0.6 volt drop here, and we want a current of 1 milliamp or 0.001 amps, we need to we can do a quick calculation of 1.6 volts minus 0.6 equals 1 volt. That would be at the low end. That would be we're going to do a calculation for the low end of this resistor value. So we've got our volts equals amps times ohms. So 1 volt equals 0.001 amps multiplied by some resistance. Okay, we do a little arithmetic, divide the 1 volt by 0.0001 amps equals R, and we get 1,000 ohms equals our resistance. So that's the low end of this resistor, and for the high end we'd do 2.0 volts minus 0.6 equals 1.4, and that should work out to be 1,400 ohms are for the high end, and that would just depend on what this LED value is. And I chose this 1 milliamp because that should be enough to turn this transistor on adequately, as well as not dim this or overdrive the microcontroller that's trying to pump current into that LED. So for this resistor, we're going to say it's going to be 1,000 to 1,400 ohm, and he should be able to start with a 1K resistor, 1.1, 1.2, whatever, until he feels he has adequate brightness of his LED when he does a quick test of that. Next, we need to know, what's this resistor value? What can we do with that? Well, with this transistor fully on, we have a saturation voltage somewhere in the 0.3 to 1 volt neighborhood, and that's the voltage drop from here to here. It's going to be in this 0.3 to 1 volts. So since we have a 12 volt supply, we're going to have a voltage drop here between this point and this point. We know that's going to be somewhere between 3 and 3.2 volts. If we add these two together, we'll find the voltage drop that we need from here to here, or calculate this resistor value. So we're going to have a range from the low end. We need to dispose of 3.3 volts to 4.2 volts. Okay, so we can, again, this is going to be our, and we're going to have an overall current from here to here. This entire current is going to be 20 milliamps. Okay, so V equals IR again. We'll start with our low end, so we're going to have to drop 12 volts minus 3.3 volts. So 12 minus 3.3 equals IR. This is going to be 8.7 volts equals current's going to be 20 milliamps, so it's going to be 0.020 amps times R. We'll do some quick math on that with a handy dandy calculator off to the side. 8.7 divided by 0.02 equals 435 ohm equals R. And then for the high end, we're going to have 12 minus 4.2 equals IR. That's going to be 7.8, I think, equals current 0.020 amp times R. Do our handy dandy math again. Divided by 0.02. We get 0. Just do the math on here for anybody who isn't very good at algebra. We get 390 ohms equals our resistance. So this resistor needs to be somewhere between 390 and 435 ohm. Now he could go outside that range a little bit. He might be able to go as low as a 330 all the way up to 470, and it's probably going to be okay. He may go to the lower side just a little bit. Like I said, this resistor up here is a little bit multiplexed, so he may need to overdrive this LED a little bit, which should be fine. You may have to check the data sheet for that LED, but it should be fine to be overdriven for very brief periods of time, which may also be the case with this LED. It may be being overdriven so they can be multiplexed and still have adequate brightness. So hopefully this helps him out. You may see some additional comments if he has a little trouble, but hopefully there's nothing too advanced here. I did kind of put this circuit together. Hopefully this is coming through clearly. I have the 2N222 transistor. We've also got, this has the base. Over here is the emitter, collector. The LED is connected to the collector. I've got my resistor going to 12 volt power. Then I have my 1K resistor here. We'll hook it up. We'll see if it works okay. I am using a 12 volt supply. My LED is not the same as his, so I use a slightly different resistor value to correspond to my LED. We'll hook this up. We'll see what happens. Since there's this 1.6 2.4 volts up here, I'm going to use just a AA battery to simulate that coming on. Here we go. See if I can get this on camera. So with the 1.2 volts connected up, we do get the LED to light up. So should work out. This is the wire that would go to this LED. Hopefully I've included everything that he would need. If not, I'll redo this video and post it again. Good day and good luck.